Hello, everyone. It's a pleasure having you all joining us this evening. Tonight, we are welcoming Daniel Gang to give a tech talk on Kubernetes and Docker. Daniel, whenever you're ready, please take it away.
All right. Thank you, Lucas. And hello, everyone, and welcome. I'd like to start by thanking Pressful for sponsoring this tech talk. All right. Today, we'll be talking about two of the most popular tools in the container world, Kubernetes and Docker Swarm. Before we compare these tools, let's examine a common problem. Our applications are getting more complex. They don't just serve a single, simple purpose anymore, and instead, we're dealing with a collection of different services all working together. So let's say that you've just launched a cool application. What would you do if your application suddenly went viral overnight? Could your system and servers handle all the pressure? Maybe you can handle a couple of friends easily, but how about 1,000 random users? You don't be able to manually spin up new instances, manage deployments, and ensure everything is running smoothly when the demand explodes like that. This is where a key concept comes in, scalability. A scalable system is one that can handle a growing amount of work. And the way we achieve that is through a concept called orchestration. The main challenge is that we're facing today is that a modern application is made up of multiple different pieces, and we need a way to have them work together seamlessly for many users at once. For how orchestration comes into play for this, you can think of it as a conductor of an orchestra. Each container becomes an instrument, and the conductor ensures that they all play in harmony, scaling up or down as needed, without missing a single note. That coordination is exactly what orchestration gives us, a way to keep applications running smoothly, even as complexity and demand grow. Orchestration and scalability are for building resilient systems that become long-term solutions, not just temporary fixes. Okay, let's talk about Docker Swarm first. Docker's native orchestration tool is built directly into the Docker CLI, making it incredibly easy to use. What makes Swarm so appealing? Well, it's all about simplicity. It's easy to use in that you can set up a Swarm with just a few commands, which is perfect for developers who are already comfortable with Docker. And no additional, excuse me, no additional setup is needed. Since it's a native part of Docker, it works seamlessly with your existing Docker workflows and tools. For its features, Swarm focuses on the essentials only, defining a desired state, services, and scaling. Now let's take a look at the core parts that make up a Docker Swarm. A manager node is the brain of the swarm. It handles all the orchestration tasks, such as managing the cluster state, scheduling services, and scaling. The worker nodes are where your containers are actually running. They receive and execute tasks directly from the manager nodes. And finally, a service is the central definition of your application and Swarm. It describes what you want to run, including the container image, the number of replicas, and the networking settings. Okay, to make this more concrete, let's take a look at what it actually feels like to use Docker Swarm. The setup itself is pretty straightforward. You can turn any Docker host into a Swarm manager with a single command, which is Docker Swarm init. Then, if you want to run a service, say Nginx, and scale it out to 3 containers, you can just type Docker service create replicas 3 Nginx. That's it. In 2 commands, you have created a cluster and deployed a load balanced web service. This simplicity is one of the biggest appeals of Swarm. If you already know Docker, the learning curve is almost flat. Okay, now let's talk about the big one, Kubernetes. Developed by Google, Kubernetes, or K8, as is often called, is the golden standard for the container orchestration. Why is it so powerful? Well, it's a complete ecosystem. K8 handles everything from deployment to scaling and management of containerized applications. Let's break down 3 of the most important parts: pods, deployments, and services. Think of a pod as a smallest deployable unit in Kubernetes. It is a single unit that can contain 1 or more containers. If you're running a single container like Nginx, it runs inside a pod. This is the fundamental building block of any application in Kubernetes. A deployment is what you use to manage a set of identical pods. It is a higher level object that tells Kubernetes how many replicas of your application should be running. The deployment's job is to ensure that the specified number of pods are always running so that automatically creating or replacing any of them should they fail. Finally, a service is how you expose the application to the network. It provides a stable IP address and DNS name for a set of pods so that the other parts of your application or even outside users can access them. For Kubernetes as a package, the core features include, number one, self-healing. If a container or node fails, Kubernetes can automatically restart or replace them to keep the application running. Number two, automatic scaling. It can scale the number of running containers up or down based on the metrics like CPU usage. Number three, advanced networking. It provides sophisticated networking options, including load balancing and service discovery. Think of Netflix for a moment. On a Friday night, when a new show drops, the traffic can surge by literally millions of users within minutes. Behind the scenes, Kubernetes is scaling up the containers automatically so that your stream doesn't buffer, or at least, hopefully, not for too long. But all that power comes with a price. Kubernetes does require you to have a deeper understanding of its many components to reach its full potential. Its richness and extensibility, however, make it the de facto standard for complex, large-scale applications. Now, let's take a look at how Kubernetes deploys apps. The idea is similar to that of the Docker Swarm, but the commands do show you how much more there is under the hood. For example, you might be deploying the same Nginx service with kubectl, create, deployment, Nginx, image equals Nginx. kubectl, scale, deployment, Nginx, replicas equals 3. On the surface, it looks just as easy, 2 commands. But behind the scenes, Kubernetes is creating pods, managing a deployment object, assigning workloads across nodes, and setting up networking. That extra layer of abstraction is exactly what makes Kubernetes so powerful. But it also means that you need to learn all of the terminologies and architecture before you can actually really use it effectively. Okay, now that we've seen both tools in action, let's dig into some of the real-world challenges that you might face while using either of them. Docker Swarm shines in its simplicity, but that simplicity also creates limitations such as feature gaps. Swarm doesn't support native auto-scaling. If traffic spikes, you will have to handle the scaling yourself or wire up external tools, which is not always ideal. 2, smaller communities. Because Kubernetes has become dominant, Swarm's own ecosystem has slowed down. That means fewer tutorials, fewer extensions, and less long-term support. Number 3, limited adoption. Because it is rare to see Swarm running at large enterprises, it's often actually used for test environments or smaller teams who just need something more lightweight. In other words, Swarm is great for getting started, but it might not grow with you, it might not grow with you if your system or your team doesn't gets much bigger. Kubernetes, on the other hand, is exactly the opposite problem. It gives you a lot of power, but you need to pay for it in complexity. The problems are, number 1, YAML sprawl. Large deployments can mean managing hundreds of different manifest files. For new teams like most of the developers starting out, just keeping tracking of them can feel very overwhelming. Number 2, it has a very steep learning curve. You need to understand concepts like pods, services, ingress, and much more before you can actually use Kubernetes. It's not just a tool, it's an entire ecosystem that you have to learn. And number 3, operational overhead. Out of the box, Kubernetes doesn't give you everything right away. For production, you will need to add add-ons for monitoring, logging, and security. That means much more moving parts to configure and maintain before you can even get the deployment started. So, what does all this mean for us? Which one should you choose? Well, it all depends on your needs, and the trade-offs are clear. Swarm keeps things simple and fast, but lacks depth and longevity. Kubernetes gives you scale and resilience, but at the cost of complexity and overhead. The key then is to choose which pain points that you want to live with. The limitations of Swarm, which is great for small to medium-sized projects, or the complexity of Kubernetes, which will show you how to handle unpredictable traffic patterns for large-scale applications. At the end of the day, learning either tool will push you beyond just writing code. It'll also teach you how to think about systems as a whole. Understanding scalability and orchestration is exactly what separates a good developer from a great one. So I'd like to challenge you to build your next project with one of these tools. And here are some more documents that for further reading that you can check out afterwards. And I'd like to close out the presentation by thanking Pressable again for sponsoring this Tech Talk. Thank you.
Thank you, Daniel, for that wonderful talk on Kubernetes and Docker. Personally helped me refresh on Docker Swarm, specifically since I haven't yet gone super deep into it. So it's great to see that it makes it easy to get started, while Kubernetes is definitely still a powerhouse when you're ready to scale. So yeah, thank you again, Daniel. We'll leave it at that for tonight. Thank you everyone for coming, and we'll see you at the next one.